Yes. So have you gone through the code that I sent you
Uh,
yesterday? Means like
Not yet. Not yet.
okay,
Yeah, I
okay,
will try to do.
okay. Means like okay. So means basically you have got what was
Yes.
told on the yesterday's class, right?
Yes, correct.
Okay. So do you have any doubts till now? Means like in any part like
Uh,
missing value or outliers or data and type inconsistencies?
no, so far, yeah. Maybe if I try it, I will get some doubt. I will come with you tomorrow.
Okay, okay. So basically,
Mm-hmm.
I think they have sent you the this notebook as well. Because I have sent
Yes.
them this file. Okay. So
Yes.
let's
Yeah, I
start with.
got that note as well. Mm-hmm.
Okay, fine. So basically, today we will start with univariate analysis. Okay.
Mm-hmm. Mm-hmm.
Basically, to tell you what univariate analysis stands for.
Can you make it full screen?
Yes, it is. I think is it not
Oh,
this screen?
it's full? Oh, okay. It looks like small for me. Might be the. Okay. Yeah, please go ahead. Yeah. I
Okay.
think same.
So, yes. So in today's video, we will see in today's session we will see what is univariate analysis. Okay,
Mm-hmm.
univariate analysis. So basically, there are three types of analysis, right? Like one is univariate analysis, where we deal with uni means basically one, okay, and variate means variable. So in univariate analysis, we deal with one variable, okay, and there is another analysis that is bivariate bivariate analysis, okay. So in this we deal with two variables, okay, and we
Mm-hmm.
have another that is multivariate.
Mm-hmm.
In this we deal with multiple variables
Mm-hmm.
and try to see the relationship between them, okay. So basically we have few rows or few columns, okay. So in univariate we try to analyze this single column, and we'll try to see by drawing some graphs like box plot, or there are some many other different plots like counter. We have counter plot, okay, and we try to draw them and see if we can get any insights out of it, okay. First of all, what
Yes.
we do is we try to see in our data where whether there is uh, whether the column, okay, so whether this column particularly whichever we are dealing with is do it contain your numeric data or it contain categorical data, right? Our first job is to figure out, is the data that is this column contains the data that is numeric or categorical. By numeric I means, for an example like age, okay. So your age is in numbers like 10,
Mm-hmm.
20, 21, 23, or 40, suppose like that, okay. So your age is numerical data, and categorical data, suppose say for example rating, like you rate any service, okay. So you say good or you say excellent, okay, or you say bad, okay. So this will be
Mm-hmm.
considered as your categorical data, okay. So this is in
Mm-hmm.
textual form, right? So this will be considered as your categorical data. So
Mm-hmm.
so the process of dealing is different from numerical data to categorical data. Like the technique that we follow on our numerical data will be different from categorical data, right? Suppose say
Mm-hmm.
if we want to deal with age, right, so it will be the techniques will be different that will be used from if we are dealing with a gender, because gender is like mostly male and female, okay. So because
Mm-hmm.
since this is a categorical feature, categorical variable,
Mm-hmm.
okay, so like because it is male and female, like it is good, excellent, bad, okay, so it is a
Yes.
categorical variable. So
Mm-hmm.
we try to convert this categorical data into numerical data. So there are many other techniques like you give wherever suppose say in this category like
Mm-hmm.
gender, we have two feature like male and female. So we will try to convert this variable into numerical form, okay, so that we can perform computation and we can give this column to our algorithm, okay, because our algorithm don't understand this categorical data. Like our algorithm don't understand what good is. Our algorithm don't understand what excellent is or what bad is, but our algorithm can understand these numbers. Like it knows that 20 is lesser than 21, okay. So that's why we need to convert this categorical data into numerical data. But how do we do that? So there are some different techniques. Like there are one hot encoding, okay. So what do basically in hot encoding does, okay. So just I'm giving you a overview, then we will deep dive into a univariate analysis, okay. We will see some how it works. So I'm just giving you an overview. So suppose say you want to convert this categorical variable, that is gender, to numerical variable. So what you will do is you will assign, suppose say you are assigning male as 0 and female as 1, right? You can do either way, right? You can assign female as 0 also and male as 1 also, okay. So what you will do is wherever the value will be m or male, so this value will be replaced with 0. Wherever the value will be female, it will be replaced with 1. So this is the how we can convert our categorical variable into numerical variable and give this data to our algorithm so that it can perform computation to it. You got this?
Yeah. So, okay. So in this case, for example, you took it like gender, it's only male and female. For example, if there is a future address, it has multiple lines, right?
Like
So
address.
how does it work?
Like address, okay. Suppose say we have address. So address might be like different. Suppose see if the address for every line, every single row is different. So it might be very difficult to figure out, or it will basically it will be of no use for our algorithm if this every row, the address of every people or every person is different, okay. So this address is particularly of no use, like mostly, okay. But what if we have like 2 or 3 or like discrete number of, like, see, there are a concept that is discrete and continuous, okay.
Okay, now I got it. Okay.
So if you have your data that is discrete, so you can there you can perform your one hot encoding, like this was discrete, like 1 2 or countable numbers. But if it is continuous, like you have undefined number of rows, so there you can't perform this technique. So you have to try different other techniques, okay. So so this technique can be performed in like rating, right? So there is like good, excellent, bad. So you can convert these categories to, like, you can see that bad, if wherever the bad, replace it with suppose say for an example -1. And since good is since excellent is better than good, so you will assign good as suppose say 1 and excellent as 2. So it will be replacing these values.
Okay.
So this is how it is done, okay. So this is how we deal with single. In this univariate analysis, we try to first draw some graphs, we try to plot some box plot, counter plot, and we draw pie chart, okay, and we draw some histograms. We will see what are those plot basically is and how we can draw them, okay, with Python code. And we try to plot some distribution graphs, how our data is distributed, okay. And then we see what is the mean of our data, like mean of this single column, what is the maximum value of this single column. Basically we try to find get the idea of how our data is, like basically we try to get insights from a single column in this univariate analysis.
Okay, gotcha.
Okay. So now starting with like yesterday we dealt with a data set that was a Titanic data set, right? So in today's video also we will be dealing with the same. I will be using a different new notebook. That will be a Jupyter notebook. Okay, so can you hear me? I think your network is low.
This meeting is being recorded.
So can you hear me? I think I got. So am I audible to you now?
Yes, yeah.
So so did you miss anything?
Yeah, actually, what we saw yesterday, yeah, that was last.
Okay,
Mm-hmm.
okay, okay, okay.
After that, I didn't
So
hear
we
anything.
were
Yeah.
here. Okay, so in today's
Uh,
in today's session.
I'm not seeing anything, just like black screen. I'm seeing only your name.
Okay, so is my screen is not, wait, huh? I think yes, I haven't
Yeah.
shared my screen. So
Okay.
so now can you
Yeah.
see the screen?
Yes. Mm-hmm.
Okay. So basically, yesterday we dealt with all these things. Okay, so we will try
Sure.
to do perform all these techniques or steps or
Mm-hmm.
these all these techniques. Okay, in our Jupyter notebook. Are you familiar with this Jupyter notebook?
Yeah.
Uh,
For Python, right?
this yes, right.
Mm-hmm.
So
Mm-hmm.
you can have different options here. You have this cell here. You write your code, and by pressing shift plus enter, your code will be executed. Okay, so basically we will try to see a Titanic dataset that we dealt yesterday, and we'll try to see some insights for a single column. Okay, so
Okay. Yeah, a quick question, Mr. Pranjit. So can we use Colab for this code? We have
for
to go to
this
the GP.
univariate analysis, right? Yes, we can use.
Uh-huh.
I
It's
have to
easy.
just,
I don't want to download
okay, okay, okay.
Jupyter.
Just I have to create a new notebook. No, because again I have to take the test. Okay, I will do that because I don't use much of the time this Google Colab, because I will
And
have to
space is
import
there.
the dataset here. Okay,
Okay,
so
you can show me Jupyter. I will. It's the same thing. I can
wait,
use it here as well. There is no change on it, right?
wait, just
Yeah.
a second. It will require, I can do that, but it will, I have to import the dataset. Okay, so
Mm-hmm.
now we are good to start. Okay, so basically we will try to draw some counter plot. uh, we will have our categorical data. Okay, so we will be dealing with our categorical data, and we'll try to analyze it. So we'll try to plot a count plot. It should be not text. And then we will draw a pie chart, so that we can get the distribution of like what are the how our data is distributed for a categorical variable, and then we will do for a numerical variable. Okay,
Mm-hmm.
numerical data. The graph will be different for the numerical data. For numerical data we can use histogram. And we can draw a plot, and the data we'll be using will be our Titanic dataset only. Okay, the dataset that we have used yesterday. So it will be our distribution plot, and then after finally we will be drawing a box plot. Okay, so that we use for plotting our outliers. Okay, then we will see age, like min max for variable minimum value or maximum value, and mean and skewness of the data. Okay, so the data is the data sheet is the same. Like it have passenger ID, it has survived either the person on the Titanic data set this person survived or not. 0 means it didn't survive, and 1 means the person survived the accident. Okay. And P class is the passenger class. Okay, so in that Titanic data set there were 3 classes ranging from 1 to 3, like 1 being the most higher class passenger, and 3 being the lower class passenger. Okay. And this is the name of the passenger, and this is the gender, and this is the age, and this is a number of your sibling, SIB sibling, and SP for spouse. Okay, so is there any sibling or spouse for this person? So yes, there was one sibling or spouse for this person. Okay. And this parch is for your parent child. Okay, so this is any parent or child for this person was there in the ship, so it contains that. Okay, so this person have one parent or child in that ship, so this person have 2. Okay, so similarly we have a ticket, what was the ticket number. Okay, and we have the fare, what was the fare for that passenger, or for the passenger class ticket. Okay, and we have a cabin, so is the passenger got a cabin or not. So in this data set you will notice that only passenger class, that was 1, so the higher passenger class got the cabin. Okay, so you see this second is C85. Yesterday also we saw that there were many number of cabins that were not filled, like 300, around 316 I guess. So those people didn't got any cabin, so because the cabins were assigned to only passenger class, those were 1. Okay.
Okay.
And this is embarked, where that means from where the passenger have joined the ship. Like this will these are the 3 places from where the passenger have joined or entered the ship. Okay, so these being the places, name of the places. Okay, so now we will start, and we'll try to first of all try to draw a count plot. Okay, so first thing that we have to do is we have to load our data. That we have to always do is, before loading our data we have to import our libraries. Okay, so I'm importing pandas as PD. Okay, so PD is your alias. Okay, like it is a short name for your pandas function. And now we are using a Seaborn. Okay, Seaborn is a library similar to matplotlib that we have used yesterday for drawing graphs. Okay, so now we will load our data. So we will load it in a DF. We will assign the data frame name as DF, and data read underscore CSV. Inside the CSV we will paste the path of our data sheet. Okay, so here I'm copying the path of our data sheet, and inside this you will be pasting your data sheet name. Okay, so it will be inside your brackets, means quotes, remember this. Okay, and you have named your data frame, like here your entire Excel sheet or the CSV file will be stored. So if you want to see your so here this code is executed. Okay, so if you want to see your code, so you can say df.head, so it will basically show you the 5 rows of your data, first 5 rows of your data. Okay, so this is the data that we have seen exactly. Okay, so let me just give it a name, Univariate. Okay, so now until this everything is cleared. Okay, so so now we will try to draw some count plot. Okay, so this is for your categorical data. Categorical data is similar thing that we have seen, like age, or your name is also categorical data, but since it is a continuous, so it is mostly of our no use for us. And like this gender or sex is your discrete, so it have only 2 variables, so it is discrete, so it is will be useful for us. This cabin is, we will see how it works. Okay, so we are drawing a count plot for now. Okay, so we will be using embarked is this, and it contains only 3 variables, right, like C, S, and C and Q. Okay, so here you have C, S and Q. This is the name of the initials of the name of the place from where the passenger have joined the ship, okay, entered the ship. So we'll try to plot a graph out of that, okay. So we will see how many people from S joined the ship, and similarly for other variables as well, and we'll try to plot it, so that will be easy for us to visualize, okay.
Yes.
So we are using SNS. So SNS is the seaborn that we have imported on our code, imported seaborn as SNS. So it will basically help us to visualize our data, okay. So SNS dot, we have a function that is that has the name count plot, okay. So basically it will tell us it will count the number of variables, and it will plot them, okay. So inside this df, so this df is the data frame, okay. So that we have that we want to use, and we have that inside that which of we want to plot our count plot, and inside this df we have to pass the variable of which we want to draw the plot. For here in this case we want to draw the plot of embarked, okay. So I will spell embarked here, because this was the name of the column here, okay, inside quotes. Remember this, inside it should be inside quotes, okay, and round square brackets here. So once I run this function already contain the code of how to plot, how to first count the number of S, C and Q, and then draw the plot, okay. So just when I hit this enter, so it have plotted the whole graph, you see.
So yeah, it took only the 5 rows, right?
5 rows. No,
Yeah.
it took the complete, we were having 418.
five.
Yes. So here just we are displaying those 5, we are not doing anything, just we are displaying this. We have inside this df we are having 418, approx 418 number of rows, okay. So for 891, okay. So this data sheet contain larger number of data. We have 891, okay. So now you see that S people that have joined us from S are approx 600, like more than 70 or 80% people have joined from S, and like 180 people have joined from C, and similarly from Q around 80 people have joined. So this shows that this is, the people have the maximum number of people have joined from the S place, okay. So we have got this insight by drawing this count plot, okay. So now we
if you
will
want to yeah, I'm sorry to interrupt. If you want to limit the number of rows, how can you do the graph?
we will
So
first of all create a new data frame that contain a specific number of data rows,
Oh, okay, then, okay, gotcha.
okay.
Then we
So we will create a new data frame that will contain only half number of rows, or whatever you can specify
we
it.
have to restrict the data from there. Okay.
Yes,
Yeah.
okay. Now we will try to take this column, okay, gender or sex, okay, and we'll try to draw a pie chart and see how many numbers of what percentage, what proportion of male were there in this ship, and what proportion of the data out of which female were there in the ship, okay. So we will try to draw a pie chart, okay. So similarly, same first of all we have to give the data frame name, and inside this we have to pass our column name, okay. So and then what we have to do is we have to count the value, and that can be done using value underscore counts, okay. So remember, you don't have to remember all these functions, okay. So you don't need to learn value underscore count or count plot or whatever function we are using. You can just go to documentation or and see which function can be used for performing certain task, okay, because there are many numbers of function, okay. So as you will start working on it, like most of the time we 80%, like most of the time we use only few functions. so those will get remembered to you. Okay, so here we are using value underscore count function. Okay, and then we are using a plot function to plot our pie chart. Okay, so inside this there is a parameter that is kind, and inside kind we have to give which kind of chart this should be. Okay, so we want this as a pie chart, the round one. Okay, circular one, and in this we can give a parameter that will be auto PCT. Okay, so we just want to give a decimal place up to 2 decimal place, because since it will be a proportion. Okay, so it will give us the value of in a proportion. Okay, so like 78 point something 78.908 percentage of the people were male. Okay, so it might go take longer, like 78.9678. So basically here with this thing we are limiting the decimal place up to 2. Okay, so it will be showing us only up to 2 decimal places with this code, and this code is defining that we want our plot to be a pie chart. Okay, and here we are saying that count all the values, like we first count the values and then from this particular column. Okay, from this column of this data set. Okay, so when I run this, I'm getting a name that value underscore count. Okay, so it is not count, it is counts. Okay, so basically you will find, like, you can just give this error to Google and you can try to find what the possible reason for this error. Okay, when you start coding on your own. So since I am okay, so here you can see that only till 2 decimal places we are getting our output, like 64.76 percentage were male, and 35.27 percentage of the data were female. Right, out of these many rows. Okay, so similarly you can do for numeric data as well, like you can draw histogram. That will be like, for the histogram you have to import. Let me do it quickly. Okay, because it will get boring, like drawing plots. Okay, so pie plot as PLT, because like this visualization will be important. Like these are the some basic ones, but as you get advanced you will try to include, see this is a single variable. Okay, so here we are just using one variable. You see here we have used one variable. Okay, inside this one variable we are trying to analyze and see what are the patterns. And in the bivariate it will get a little bit complex, in that we will be using 2 columns, like suppose say this ticket and fare, and we'll try to draw some plots out of it, and so it will be a little bit more complex, and it will give you a further insights about your data. So this is the basic foundation of your EDA, or visualizing the data set. Okay, so in your numerical data is like age. Okay, so in this we will try to draw some plots with age. Okay, so here we are using matplotlib, and inside matplotlib there we have a class that is pyplot. Okay, and we are using it as PLT. So wherever I will be using PLT, it will say that it will include this matplotlib. Okay, so every time I don't have to write this matplotlib, I will just write PLT. Okay, so I'm writing PLT dot, since I have to draw histogram, so I will use hist. There's a function that name hist. Okay, so inside this I will pass yes, so inside this I will pass df, other data frame that you have assigned earlier, that we named it df, and I will write square brackets, and inside this square brackets I will give the variable name. Okay, that is age. Okay, and I will give how many bins do we want. Bins, you will get what the bins is. Let me just write it first. Suppose say I want 5 bins, and when I hit enter, you will say we got the 5 bins, like 1 2 3 4 5. So it basically divided our age into 5 parts, mm, like 0 to 18. It classified them from 0 to 18, okay, and then from 18 to 31, and then 31, so around 31 to 48. Basically it divided in equal 5 parts, because I have specified here bin is equals to 5, okay. So then it has plotted. So this graph tells us that most of the people were from 18, between 18 to 31. You will see here around 345 people were had age that was between 18 to 31, okay. And similarly the lowest people were from this 64 to 80, okay, like it is around means around 1 or 2, right, okay. So this is how your data gets plotted for your numeric data. So you see the data that we have drawn for categorical data was different from our numerical data.
Correct. So when you go a little up, yeah. So it shows some number array. So what is that?
Array. So it shows as the array, okay. So it have created some calculation, and for our advanced understanding, like these are the array that are created, like there are the 5 bins. So it have created 5 values like 100, 365, like first bin was around 100, right?
Okay, that.
Yes, it specifies this.
Okay.
And second
So-
second bin was your 346.
Yeah, 346.
So it is 346, and this is your people from 28 to 47 was 188, and similarly for other values as well. Yeah,
Oh, okay. Yeah, now I got you.
okay.
So those, yeah.
And similarly this value as well, it stands for some values like yes. So starting value of this bin, so it was 0.48. So it started from 0.48, and it goes up to 16.3, right? It goes up to 16.3. So people between 0.4 age, like you may think of it as 1 age to 16 age, people were 100 people were there.
Yes. Okay, now I got you.
And people that have a age between 16 and 32 were 346.
Yeah.
Similarly for a third bin or third group, that was between people between 32 and 48, there were 188 people, and similarly for others. So this is the insight that we got from our histogram.
Okay.
Okay, and similarly now you have our dist plot. For a while I think it will be some hard to visualize or understand how dist plot is, but you may just note it, or you may read some articles about it. So, okay, you can you can take it as a assignment, or your read article
Sure,
or
yeah.
about
Us, yeah.
dist plot. Okay, so basically I'm giving you just a plot and drawing a dist plot for our age numerical data, and we will see, we will basically draw the dist plot for our age. Okay, so we are using Seaborn library SNS, and inside that we have a dist plot, and inside this we have to give our data frame name, and inside that we have to give the variable name, that is age. Okay, so it will draw the distribution graph.
Okay.
So this is your distribution of your graph. Okay,
Okay.
so what these values are, like how these values got created, you may you will understand better if you once you go through that. Okay, because let me give an let me just give you an understanding. If you sum this all up, you will get a value around 1. So this is plotted around that, like that, so that wait, this will be a little bit difficult for me to make it understand in like few time. It will take a few longer. So let's skip this part. You may go through an article or blog,
Sure.
and then we will
Yeah.
discuss it. Okay.
Discuss, yes, sir.
And then at the last we have a box plot. A box plot we have also seen yesterday, that basically help us to plot or identify outliers, right? So so in the yesterday's code we see that how we plotted outliers. So that was in code, I think. Yes, so this was the code, right? So this was in the backend, and if I write in just using a library, so this can be done in just a single line, or you may say a single word. So I will just say a box plot df, and inside this age. That's it. So yesterday I've seen this code was running at the backend. Here we specify everything, like we gave it defined a value like q1, quartile 1 and quartile 3, and then we defined upper lower bound and upper bound. Okay, and then we said anything that is below our lower bound will be considered as outlier, and anything that is above this upper bound will be considered as outlier. So here we done all the things by our own. Okay, so but what if you want to do that in a single line? So you can use this box plot library. Okay, so once I hit enter, it will be giving me the same box plot. Okay, so since the data set is different, here we are using 891 data. So the graph, our plot is little bit different. Okay, so in this data set we used around 416 rows. So same graph, around same graph you got with this single line. Okay, so this is for this case we have our upper bound is at around 67 or 64, sorry. So anything that the data point above this are considered as outlier. Okay,
Okay. Okay.
so we may drop them or remove them and fill those places with our mean, median, mode, or whatever, basically. Okay, so suppose we want to find the minimum value out of this age. We are having this column age, and we want to find using Python. So, what is the minimum age of any variable? Suppose here we are taking age. Okay, so we have a just function that is min. Okay, so you will just give like dot min, and you will hit enter, so it will be giving you the value for the minimum value. Like this code contain a 0.42 age, so here somewhere the age will be like 0.42. Okay, so I don't know why, but it is 0.42. It could be this. You may see this.
Yeah. Okay. Yeah.
So it might be your typing error or technical glitches. So this is the whatever the reason may be. Okay, so it should be like 42, I guess, but due to some reason it is a point is there. Okay, so you can also see your find the maximum value. You may similarly have to give age. So where it will be helpful, it will be helpful while writing a code similar to this on the back end.
Yeah.
So suppose say at any position or at any point you want to take the minimum value and check if anywhere or perform any computation with that. So you can just write this age dot min, and you will get that value, and you can perform computation and check for any other variable with it. Okay, and similarly for max, we have maximum value, we have max.
Okay.
So it will give you the maximum value. Okay, and suppose say you want to find the mean. Similarly, you have a function that is dot mean, and for age we have mean, and now we can draw, like you can see our mode, or similarly median also. Okay, 24, sorry, 0. So 0 would be have like 24 times. uh, in this data set there would be some errors, so due to it, so yes, so basically you may check like for the other values as well. Okay, so for median and as well. Okay, fine.
Yeah, I will do that.
Any doubt till here, like means any confusion or
No, so far I'm good. Yeah, I will try. Definitely today I will try to do something. Yeah, maybe I will get some doubt.
so I will be sharing this notebook to you. Okay, and then we also have an interesting topic, like we have a pandas profiling. Okay, so it is an a very interesting tool that you can use to just like to just make your report of your data set on just a few lines. Okay, so I will be using a local host, doing this local host using this Jupyter, because it generates an HTML file. So it will store your HTML file on your local system. Okay, so what it will do is it will take your Excel, it will take your data set and it will convert your, and it will give a report out of your data, like it will give different insights out of your data. Okay, so how to use it? You can use pandas. You have to import pandas, and inside your pandas you have a function that is, and you will give your CSV, and you will give your train dot CSV. Now inside df I have my data set, and I can see the head, and it works fine. And now if you want to, first of all, before using this pandas profiling, you have to install it. Okay, so you can do that by doing this pip install pandas profiling. So this you can do on your terminal as well, and you can do it here as well. Okay, if you write this exclamatory mark, now you can write your command of your command prompt if you are on Windows. Now it will take some time, and it will import a library, and this library is amazing because you just need to give your data frame, and it will generate an HTML file, like it will give you a web page, so that you can find information about different variables in just one click. So let it download.
Can you say it one more time? What does that? So it will create a HTML file.
Yes, so
We can use it.
So it will give you the details about every single variables, and it will basically give us a report about it. Okay.
Okay, and then you are saying some website. What is that?
It will give you a web page.
Web page. Okay, yeah.
Okay. Yes, in that web page the information related to your data set will be present.
Okay.
So that it will be presentable to your stakeholders or your team members, right, or your other developers. So it is taking a bit longer. So let us write the code. Okay, so will be like your pandas. You have a library that is this pandas profiling. Okay, so inside this pandas profiling you have to import your library that is profile report. Okay, so once you start working with it, you will remember all this. Okay, so you don't worry about remembering all these functions like capital letter or small letter. You can just take reference from Google or any other source. Now you can say prof, or you can define any variable, and you have a profile report that we imported here, we will use it. Okay, so we are saying profile report. Inside this we will pass our data frame. Okay, so just we have to do this. We have passing our data frame, and that's it. It will then you have to specify your file name, folder name, like where your HTML file will be stored. You will give output underscore file, and you will give your file name output. So it will be stored in your present working directory. Okay, so for
So
me it is,
can you comment on this line? It will
yes.
give you the present, yeah, that line. Yeah, after you write the code, can you comment like it will give you that output save in
It
something like,
will store
yeah.
the HTML web page on my keyboard just got hanged. Okay, so now can you see it?
Yeah, I'm seeing only on, yeah, see, yeah.
Okay, so you can see the web page on your current working directory.
Okay. So if we want to give the specific, we can give the location, right? In the, okay,
Yes,
gotcha.
yes.
Okay.
Just give me a 1 minute, huh?
Mhm.
Okay, so yes, so our library is also installed. So now that's it. Okay, so here you have specified your output file. So now that's it. Now we will once we run this, it is saying that I haven't given a single quote, I haven't closed the quote. So once I run this again, it's saying no module named pandas profiling. uh, Already satisfied. So you see it will take like a it will take your 30 to 15 seconds. So once this get completed, again I got another error, that is pandas profiling. Okay, if I give it another name, okay, so it is giving some errors on my file because I have already installed it. But if you will run it on your desktop, on your system,
Yeah,
it will
I'll
work
do
fine.
that.
Okay,
Mhm.
so
Yes,
the
I,
output it will be giving you the output like this. So I have already the output on my system, so due to it which it might be giving me error. So this is your output.html. Okay, so the similar output that you will be getting by running that code. Okay, so now
sure,
it
sure.
have given the overall report about my data set to me, like how many number of variables were there. Like there were 12 variables, right, that we have seen.
Yeah, got it.
There were how many number of observations? There were 891 observations. How many missing cells were there? There were 866 missing values. Okay, and
Yeah.
similarly what percentage of the missing cells were there? Like 8.1 percentage of your missing cells were there. How many duplicate rows? Zero. Yesterday also we have seen how many duplicate entries are there, right? So we got zero. So the same thing we have, this report has given to us, and this is zero. And what is the memory size and average size in memory. This is not much important, and it also given this important thing like how many numeric data is there in our data set. 5,
Numeric.
7. Because this is more important, because first of all
Okay.
you need to understand how many numerical data and categorical data are there inside our data, so that you may perform the techniques and tools accordingly.
Okay.
Then you have variables like and how many distinct values. 100% distinct values. No values means how many unique values were there. Okay, so you get basically the for passenger ID basically. Okay, so for survived, how many distinct values were there? Like 2. For survived, for survived, yes, there were 2 distinct value only, like 0 and 1. So the same thing our data is, our report has given to us. And what percentage of the data set was distinct, like 0.2. Missing value is 0. And for passenger class there were 3 distinct values, passenger class 1, 2, 3, right? And similarly for name, how many distinct values? Like 981, all the values were distinct, no repeating value. And for gender and age as well. Okay, so you see in age we have now missing values 177, and it also give us the graph like how many number of people basically here the graph is same, but just the number of bins. This graph is same, but just here we have used the 5 bins. In this case they have used around,
All.
yes, like means like more than 15 bins are there.
Okay.
So this is the power of your this pandas profiling, like it has done
Yeah,
all
it's
these
very
things.
interesting, Mr. Rajesh. Yeah.
Hmm.
Yeah. Even
Yes.
I say the reports using Airflow.
Yes.
So now it's like, yeah.
Right.
I was wondering always. I was wondering like what is machine learning? What the data analysts are doing something like that now. Yeah, yeah,
Hmm.
I got it.
Okay, so like in sibling spouse we have 8% of the 0.8% distinct values, like 7 distinct values. Like if you see here in sibling spouse, and they are like it contains the number of sibling or spouse, like 0 to ranging from 0, or this person have like 8. This might be a like something interesting. Okay, like most of the people have 0 sibling or spouse in their in with them,
Yeah.
like some have like with 1 or 2 or 3, like most of them. Okay, so basically there are 7 distinct values that you can see. Okay, and you have also parent child, and that also you can see. And here you can see like you can see correlation. Interesting thing is this, now you can see the correlation between different values. If you draw this heat map, see this for wait for correlation. If you see this graph, so basically if any block, if you see that is around this
Dark
one blue,
blue.
okay, dark blue is highly correlated, and that
Yeah.
is red, that is that is
Dark
negatively
gray
correlated.
matter.
Negatively correlated means for positive correlated means if the value of passenger increases, the value of this column should also increase. So since this is also passenger ID, so it is justified that if this passenger ID increases, yes, this passenger ID is also increased, because these are the same. So that's why it is in blue. Okay, and what this red means is if the number of P class increases, the fare charge decreases.
Okay. Yeah.
Because you see that passenger class was 1, right, for people who
Very
were
good.
VIPs,
Mm-hmm.
like the P class for 1, that was basically low. If the passenger class is low, like for 1, the fare will be high,
Yeah. True.
right?
Mm-hmm.
So it is negatively correlated, like it is around red.
Okay.
Okay, So here also you may see that around this red is negatively correlated. So passenger class is negatively correlated to age. So that means if the age is higher, the passenger class will be lower. So that means most of the time that people with higher age are VIPs. Like if your age is high, your passenger class, the number of passenger class will be low. Like passenger class is this one. So one stands for VIPs. Okay. So it suggests that if your age is higher, you might be like, if the passenger is VIP, the chances are high that your age is high. Okay, means age will be higher. So similarly for this age and passenger class, yes, this is same. And for survived and your passenger class, you will see that with this red. So if you analyze on yourself,
Yeah.
you will find some interesting things. Okay.
Sure, I will do that.
So for different data set, you may check and you will find some interesting thing. Like in this data set, it is not much, but in some data set, it is like you find some huge interesting thing. So similarly
I will
for
do
this, like missing values, you have you got some interesting thing, like for every other values there are no missing values, but for age we have 714 missing 714 filled values, and for cabin we have 204 filled values. Okay, so I think we should wind up today's class with that.
So can you share the data set as well?
Yes, yeah,
Or
I
can I
forgot
take it
to.
anything
Yeah,
from the
I didn't share the data set yesterday, I think. So I will be attaching that file as well for today. Okay.
sure.
So I'll just make this public and share it to you. Okay. So how was today's class? Means did you got any insights or means any
Class is really
confusion?
good. It's interesting. No, I'm good. Yeah. So, yeah. Anyway, I will go through today, like as you said, like I will go through some documentation. Then I think, yeah, I will get some doubt definitely. But so far, I don't have a doubt. But I have some idea. So that is the reason I can understand what you are trying to say.
Yes,
Something.
yes, that will be
Yeah.
appreciable
Easy to understand.
if you tell me how the, if you want me to do some changes, or if you have some feedback.
Sure.
Yeah.
Sure, definitely. As of now, yeah, there is no negative anything. So I'm good with whatever you are. I mean, I like the way you are explaining. So I'm good so
Okay.
far.
So
Yeah,
if there will be any suggestion or feedback, let me know. Okay.
sure, I will do that. And you can share this one. And what about the notebook? I think yesterday someone shared me as well.
Yeah, I will be sharing the
So,
this notebook to Prem, the guy who
uh
contacted me, and
same.
he will be
Okay.
sharing to you. Okay.
Okay, yeah, I will ask them to the recording video as well. It will be helpful. If I can hear one more time, yeah. So tomorrow also same time, right? No.
Yes,
I
yes,
mean,
yes,
there
yes,
is no change.
yes, yes, yes. The
Okay,
timing is the same.
yeah.
Will be the same. Okay.
Okay, yeah. Thank
Okay.
you,
See you
Ranjit.
tomorrow. Yeah.
Thank you.
Okay.
Bye.
Okay. Bye.